Let's begin. Today's September 12th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 9, 12, 16, 19, and 21. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. In the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our 3-digit solution and will let us know how many of those digits are 3. Are there no 3s, a single 3, perhaps 2, maybe even all 3 are 3. Criteria card B looks at our first and last digits, triangle and circle, and compares them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card C, again, looks at our 3-digit solution, but this time will let us know a little bit about the ratio of even to odds. Are there more even than odds, or are there less even than odds? Criteria card D will look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again looks at our 3-digit solution, but this time will let us know a little bit about its structure, so to speak. Specifically, it can tell us whether there is a pair of digits, as in the example 131, or alternatively, there are no pairs, but there are 2 different scenarios. One where all the digits are the same, as in the example 222, or all the digits are different, as in the example 134. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just discussed. Now we're going to start off with an initial proposal of 314. So the first thing I want to find out is a little bit about the ratio of even to odds. So let's go ahead and test criteria card C. Okay, so the Turing Machine does not approve of my proposal. Notice that I do have 2 odds to a single even, but since the Turing Machine does not approve of that, it's letting me know that in fact there are more even than odds. So let's go ahead and type that up in our notes in section C. And that again is that there are more even than odds. Now, there are a couple of scenarios. We could have just a minimum of 2 evens and an odd, or it could be that all 3 digits are even. We just don't know that yet. Next, I think let's go ahead and test criteria card E. Okay, so again, the Turing Machine does not approve of my proposal. Notice that I do have all unique digits, 314, so that falls under the no pair scenario. But the Turing Machine does not approve of that. So it's actually indicating that there is actually a pair of digits. So let's go ahead and type that up in our notes for section E. And that is that the solution has a pair. And since we know that we have more even than odds, that is an indication that the evens are paired up. Now again, you could still have the other be an even, where it's, it's like, for example, 224 or 424. So it still doesn't tell us whether we have an odd or not. Although, of course, we do have this criteria card A that will indicate whether we have a 3. But if that fails, doesn't mean that we could still have a 1 or a 5. Let's see what else. And because the evens are paired up, well, the evens were the first 2 digits. It would either be less than 6 or greater than 6, right? 2 plus 2 is 4. That's less than 6. 4 plus 4 is 8 and greater than 6. That's a possibility. Or it could be that maybe triangle and circle are equal. And then depending on, let's see, is there a way that we could figure out, maybe the sum is less than 6 and it's like a 2-3, something like that, maybe. Well, I don't have triangle and circle equal, but doesn't matter. Let's go ahead and test criteria card D. Okay, yeah. So in fact, the sum of the first two digits in my proposal, 3 and 1, is 4, and 4 is less than 6. So yeah, so the sum of the first two digits is less than 6. So let's go ahead and type that up in our notes. And that is that triangle plus square is less than 6. Okay, so what does that tell us about triangle or square if the sum is less than 6? Well, it seems that neither triangle nor square could be a 5, because when you add 5 to the smallest of 1, that sum is already 6. And obviously, if we add anything larger than 1, that's going to be greater than 6. So yeah, we can actually cross out the 5s from both triangle and square. Okay. Well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So remember, we didn't test criteria card A, the number of 3s, nor comparing triangle and circle. And of course, let's see, all the other 3 cards that we did test were definitive, right? There were 50-50s, and so we know that they're more even than odds. We know the sum is less than 6, and the solution has a pair. Okay, so what else can we say about triangle and square? Obviously, we do have that card. Is there a 3 or not? Maybe there isn't, and it defaults to a 1. But if that were the case, and they weren't paired up, that would mean, well, 1 plus 2 or 1 plus 4. But how would you organize it? Doesn't seem like that's possible. What about criteria card B? What if triangle and circle were equal? So it could be something like 4, 1, 4. But it could be also 2, 1, 2. So I don't think, so what if they were equal? It could be 2, 1, 2 or 4, 1, 4, but it could also be 2, 3, 2. So I don't think triangle and circle would be equal, because how would you choose if there were, I'm assuming there are, I'm not even assuming that there are no 3s. I'm assuming that triangle and circle are equal. I think they're, even if there were no 3s, I guess the only distinction is if there is a 3, then it would force it to be 2. So you could have something like 2, 3, 2. But if there are no 3s, then you can't pick between 2, 1, 2 and 4, 1, 4. At least not that I can tell. So one viable solution is 2, 3, 2. And that's if they're equal. Let's see. And then, of course, you do have the 2, 2. The other possibility would be 2, 2, 1 or 2, 2, 3, where perhaps maybe circle is larger. And so let's see what, but of course we need a definitive answer. And it could be something like 225 even, right? Where circle is larger. But let's see. So let's see, if there are no 3's, yeah, it could be 225 if there are no 3's. And it could be that circle is larger. Oh, actually, I don't think we could do that because, yeah, I don't think circle can be larger because even four would work. Again, we don't know if that third digit is even or odd. So I don't think it could be 224 or 225. Yeah, so I think I am going with they have to be equal. And so the question is it 212 or 232? And that's a 50-50. Let's see. Yeah, let's go ahead and say 232. And what if I'm wondering if we could deduce that they're equal. Yeah, let's go ahead and test the number of 3's. Yeah, let's test A. Okay, so there are no 3's. Okay, so let's just type that up. So we'll say that the solution has no 3-digit. Okay, well, let's see how that looks. So there is no 3-digit. So either we have a 1 or a 5 in our solution. And yeah, I think you can even cross out the 4, right? What could 4 add? Well, I guess you could have 414 at this point now. But no, I don't think it's going to be 414. Well, yeah, at this point, if they're equal, yeah, now I'm almost convinced that they're not equal, because now you have 212 or 414, and how do you distinguish between them? Oh, wow. Yeah, and unfortunately, maybe criteria card B will not give me the information I need, because if they're not equal, then it doesn't tell me whether triangle is greater or less in circle. So can I deduce it now? Okay, so let's go ahead and I guess type some of these solutions. So again, I think we can disqualify. I'll still type it out. So you got 212 and 414. But I think we can cross them out because they're ambiguous. There's nothing in the set of criteria cards that will help me distinguish between them. They both have a sum that's less than 6. There is a pair. There is no 3, and they're equal. So yeah, so I'm just going to type them out just for completeness. So, and I think that's it for the triangle and circle to be equal. Okay, so now what if what if triangle were smaller than circle? What does that mean? So can it be, well, I guess it could be 1, 2, 2. That's where triangle is smaller. It could even be 1, 4, 4. And again, I think those are ambiguous. Triangle is less in both of them. 1, 2, 2, 1, 4, 4. There's some is less than 6. There's no 3. Okay. Yeah, I think we can cross those out as well. They sure do seem ambiguous. Okay, so was that it? Yeah, 1, 2, 2. Well, that's the odd. It could be 2, 4, 4. No, it can't be 2, 4, 4 because that sum is not less than 6. Okay. I guess there's 2, 2, 4. But that's also, wow, wait a minute. Well, one thing I have not considered is, could it be a triple digit? I never did conclude. Well, yeah. No, it can't be a triple digit because there is a pair. That third digit has to be distinct. It could be even or odd. It just, yeah. Okay, so there's no triple digit. So what is going on? Am I missing something here? 2, 2, 4. How about 4, 2, 2? Maybe that's it. So again, I think we can eliminate this because again, it meets all the other criteria cards. No 3, triangle is less than. So yeah, it looks like the only possibility is 4, 2, 2. Because that's the only case we haven't talked about. We kind of dismissed triangle and circle being equal. We've listed a lot of candidates where triangle is smaller than circle. But I think this is the first one where triangle is larger than circle. Yeah, because it can't be 2, 1, 1, but 4, 2, 2 does work out. Okay, so here, yeah, I mean, 1, 2, 3, 4. We've eliminated 5 options, and I'm hoping that those are all of the possible combination of numbers that, sort of meet all of the 5 criteria cards. So we eliminated that. Yeah, it looks like, I think we're, yeah, let me type it up. I'm going to say we're going to deduce that triangle is larger. Is larger than circle. Okay, and yeah, that looks 4, 2, 2. So if that's correct, if it is true that triangle, if our deduction is correct that triangle is larger than circle, then that would be the solution, 4, 2, 2. Yeah. Okay. 2, 2, 4. Yeah. Okay, that's what I'm going with. I think I'm not going to cross out everything, but I believe I've exhausted all the combination of digits that would meet the criteria cards, even accounting for all the variations for criteria card B. So let's go ahead and type 4, 2, 2. So I'm experiencing a little bit of a lag here. Hopefully the numbers will start popping up. There we go. Let me just kind of adjust it. Okay, well, let's go ahead and test the proposed solution of 422. Let's go take a look and see how we did. Again, we are deducing that criteria card B. Okay, so 422. It is not 422. Okay. Okay, well, that's it. So this game is lost, but so let's go ahead. Well, if it's not that, then it's one of those that I crossed out. I couldn't see what is the distinction, because I'm pretty sure the first two can be eliminated. So what's so different about the middle three? Two, two, four. Well, yeah, they're all okay. Well, maybe I didn't account for that 5. Could that be it? 2, 2. Well, that's true. I did not type up 225. But yeah. So I didn't, okay, so I did type up 224, but not 225. But that would have been the same thing. 225. But I would have eliminated that as well, because again, all of these are where triangle is smaller than circle. We did equal. Okay, wow. Well, let's go ahead and test B, just for completeness. Yeah, okay, so they're not equal. Okay, so that means that either triangle is smaller than circle, oh, no, well, one, 4, 4. Yeah, I just don't see it. 1, 2, 2, 1, 4, 4. What's the difference? I must be missing. I must be missing a combination. Two, 2, 5. So yeah, well, oh, yeah, of course 422 can't be it. That's 6. Oh my gosh, what a foolish mistake. Okay, yeah, that was foolish. Okay, yeah, very foolish. Okay, so let me cross this out. Yeah, very foolish mistake. Okay, so, but what about 2, 2? Yeah, 2, 2, 4 and 2, 2, 5. Those are right. You know, I can't distinguish them. There is something that I am missing. And so, yeah, so this is wrong. Yeah, I don't know. I should just cross everything out here. That still has it. Let's see. I am still wondering what else I could test, or what sort of proposal. Okay, so we know triangle and circle is not equal. Oh, I see what I missed. 2, 2, 1. That's it. Oh, goodness. Yeah, so let's see. Can I undo this? Okay. So yeah, I think it's going to be 2, 2. So yeah, I think it's going to be 2, 2, 1. So I think the idea was correct, that triangle is larger than circle, but it's going to be 2, 2, 1. All right, let's try that out. 2, 2, 1. There we go. Okay, well, we'll still do the Turing machine, even though, yeah, for all intents and purposes, it was this game was lost. So let me go ahead. So yeah, so the deduction was correct. So let me undo that. Okay. So, although I'm not sure how I should, what I should submit, but yeah, I'll submit this. So C, D, E were done in the first round, and D was the only correct one. So C, D, E, and then we tested A and B, and they're both incorrect. Okay, so yeah, it would have been a win. And actually, I think had I picked the correct version of where triangle is greater than circle, not the one where they add up to 6, but where it was 2 greater than 1, it would have been even a better victory. But such is life. There are going to be mistakes made. But how did you do? Did you do better than me? Please post that on the comments. If you like the video, do give it a thumbs up. And if you don't want to miss out on any future videos, make sure to hit subscribe. Well, until next time, have a good one.